All these robots are controlled by electronics. This is a whole computer on a chip. Silicon chips are at the center of electronic brains. And an electronic brain is what you need for getting across a busy road. Just tell it that you want to cross. What makes these doors open? What about this barrier? This is an electronic eye. What's it looking for? This man's case contains an electronic ear. He uses this receiving equipment to listen to other people's phone calls. How do you think electronics might be used to control this tropical hothouse? And where else might electronics be useful?
Thank you, Mrs. Poole of Bromley South. It's good to know how you feel about the issue. But now let's continue on a more relaxed note.
Could he use electronics to control the situation? They're using an electronics kit to build a lamp switch. They need to know what each separate unit does. Their system uses a power connector, a switch unit, an output drive, and a bulb unit. On this tape recorder, you can record only if 2 switches are pressed. To build a circuit like that is easy with an AND gate. To switch the motor on, they have to press this switch and that one. In front of this giant drilling machine, there's an electronic beam connected to an AND gate. The machine will only work if the beam is unbroken, and this switch is on. Why does this safety system use an AND gate? What safety system might have helped here? This is a smoke detector. How does it work? Inside, there's a battery, a detector, a test switch, and a buzzer.
That's a smart detector, which is...
They've built their own smoke detector.
Smart detector, that's the buzzer.
They've used an OR gate. The alarm should sound if they press this test button. Or it should sound when the electronic eye detects smoke. How do you think the control systems work in this kitchen? What do we mean by control? For a sport like this, you need ball control. How does the driver control this traction engine? What other controls do you think there are? This is the governor. It makes sure the engine doesn't turn too fast. To round up these sheep, the sheepdog needs information. It has to be told what to do next. What sort of information controls its actions? How is this fairground organ controlled? What sort of information does it use? This is a musical score for the automatic orchestra. The cut-out slots in the sheet carry information to make the music. It's passed on to these pins, which control all the different instruments. So the punched cards control a complicated operating system, and the tune you hear depends on the information that's gone in. What sort of information is needed to run a railway? The lights on this panel tell them where all the trains are and which way they're going.
Martham Road, Hebden Bridge, Totmorden, Littleborough, Smithy Bridge and Rochdale. Platform 9 signal for the 11:18.
How does information get passed back down the track? What control systems does a train driver need? And what happens when control systems go wrong? What he needs is a system to control his window cleaner. Control systems won't work without some sort of detector. His system obviously works, but what was wrong with his design? A good design will solve a particular problem. Here, the problem is to stop this model greenhouse from overheating. Start with the electronics, the brain of the temperature control. Put the electronic units together so they match the paper design. Then make the operating system. If their system works, then the fan will come on when it gets too hot. Can you think of different ways of solving the problem? This tropical hothouse needs to be kept warm and damp. What controls are used inside? It's not just hothouses that need electronic care. How can electronics help to save lives? And why is it important that humans stay in control?